All right, let's go ahead and get back to live action here. And we're going to do A times A. Now, before you start, you have to check to see if you're even allowed to do the matrix. Once again, A times A is going to be a 2 by 2. See, A has 2 rows and 2 columns times another 2 by 2. The answer is in the middle, or the numbers in the middle match, so your answer will be a 2 by 2 matrix. So let's go ahead and write that down. We have a 7, 3, negative 2, and a 0. And we're going to multiply that to a 7, negative 2. See how I leave a little bit of space, leave some more space, 3, and a 0. And this will give me a 2 by 2 matrix when it's all said and done. And then we'll do B squared on another page. So let's go ahead and take a look at these bad boys here. Once again, I'm going to grab the first row, pick it up, squat it, walk it over, drop it in. The 3 hits the bottom, the 7 sits on top of that. I'll multiply those and add them. 7 and 7 is 49. 3 and negative 2 is a negative 6. We do the math on that, and we end up with a 43. So 43 is in the first row, first column. We'll do 7 times 3 is 21. 3 times 0 is 0. So a 21 will go in the first row, second column. We'll go ahead and move this bad boy down, grab the next one, which is a negative 2 and a 0. And we'll drop the negative 2 and the 0 in. So the 0 hits the ground first. The negative 2 is next. We're going to add those. Oh, I lied. How about we multiply those and then add them? Negative 2 and 7 is a negative 14. And 0 times negative 2 is negative, or 0. So we end up with a negative 14 in that corner. Negative 2 times 3 is a negative 6. 0 and 0 is 0. So we end up with a negative 6 in that corner. And that would be the answer for A times A, or matrix A squared. So squaring matrices isn't all that big a deal. Same thing we've been doing. We're just using the same matrix to multiply it to itself. I'm going to take matrix B to the next page. Let's go ahead and take a look at that. Getting all twisted up. We're going to wait for just a second. I could pause the video. No, never mind. We'll just do it. You guys can watch me manipulate the work and do all the behind the scenes stuff. I'm not exactly a professional. Didn't want to put it there. Let's take it to a blank page. There we go. Professional YouTube, Mr. Studer. I guess I am professional. I am getting paid for this, even though it's not YouTube doing the paying. Yep. So great. Go team. I'm going to do B times B. We do have a 3 by 3 matrix times a 3 by 3 matrix. The numbers in the middle do match, so the answer is going to be another 3 by 3 matrix. So long as it's a square matrix, you are allowed to multiply them together. If it wasn't, we'll step into that for the next problem. But for right now, yes, it is square. It does work. So B times B ends up being, this is going to take a minute. So we got a 2, 4, and a 1, 5, 0, negative 2, 1, negative 1, and 3. We do have that 0 in the middle. That'll make some of the math nice and pretty. But let's go ahead, and I'm going to cheat for just a second. I'm going to grab all this stuff and clone it, bring it over here, and we'll multiply that together. So times all that fun. So the first thing I'm going to do is grab this row, pick it up, walk it over, and drop it in so that I have a 1, a 4, and a 2. I'll multiply all of those and then add them. This is going to give me 4 plus 20 plus the number 2, which is going to be a 26. This answer is going to be a 3 by 3 matrix. So we'll make ourselves a nice 3 by 3 matrix over here. And first row, first column is going to be a 26. Now we're going to multiply a second row. 2 times 4 is 8. Plus 0 minus 1 is going to be a 7. 2 times 1 is 2 minus 8 plus 3. So 2 times 1 is 2. 4 times negative 2 is negative 8, and 1 times 3 is 3. We'll add those together, and that's going to give us a negative 3. Come on. We'll go ahead and do it again. 2 times 1 is 2. 4, -2. Wait, never mind. I lied. We already did that one. Let's go ahead and move on to the next row. So as I move this down here, I'm going to take the 5, 0, and -2 and plop it in, but I got to get rid of these first. So we'll get those out the road. We'll drop in a -2, 0, and a 5. We'll multiply them and add them. We're going to end up with 10 plus 0 minus 2 is an 8. 20, 0, and a positive 2 gives us 22. Let's run with 5, 0, and a -6. So 5 minus 6 is a -1. This is a little out of sorts here. We'll kind of center those a little bit. There we go. And let's do the last one. We're going to do 5 times 1. And did I not just do that one? Yeah, I did. Let's grab the last row. It's twice I did that on the same problem. Okay, so I'm going to take this row, drop it in. 3 on the bottom, -1 and a 1. We have 2 minus 5 plus 3. So 2 minus 5 plus 3, that's going to be a 0. Boom. We have 4, 0, and a -3. So 4 minus 3 is the number 1. And we have a 1, a 2, and a 9. So 1 plus 2 plus 9 is going to be 12. And there you have it, a 3x3 matrix. Pause there for just a second. Any questions you might have, hit me up in the comments. Not on YouTube. Don't comment on YouTube. Go into the Google Classroom. Send me a comment there. It can be private or public. You can also send me emails. That's fine. And if your question deserves a video, I'll do a video for it. I'll explain that a little bit better. If your question is just something simple, I'll probably just answer to you, specifically. But any math related stuff, let me know, and I can get you that. All right. Love you guys, and let's go ahead and move on to the next one. So now they're looking for C squared, and when you look at C, it is a 2x3 matrix. There are 2 rows and 3 columns. So if I multiply a 2x3 matrix to a 2x3 matrix, the numbers in the middle do not match up. So this particular one is not possible. And they even give you the option by saying, hey, evaluate it if it's possible, and this one is not possible. However, I to the power of 4, this is kind of silly. What we're going to do is we're going to start with, they want to do I times I times I times I. Well, if you think about it, we can do I squared right here, and then we'll have this answer. And then they just want you to multiply those together. But watch what happens when we do I times I. This is what's known as an identity matrix. So I equal to 1, 0, 0, and 1. What we do is we have ones on a diagonal. This is what's known as an identity. If you remember, we did the identity property, and we said 7 times 1 is 7. Anything times 1 is itself. This is like saying I have a 1x1 matrix times a 1x1 matrix. And 7 times 1 is 7. This is also an identity matrix. Another identity matrix would be ones going down the side. So if I had a 3x3 and I had a bunch of zeros, this is also known as an identity matrix. And if you notice, when you multiply this to a matrix, you get itself. Nothing changes. So we'll go ahead and do the math on this. They want to do I to the power of 4, and it's kind of a joke. But they want you to try it out just to see, introduce you to what an identity matrix is. So in order to do this one, we're going to do a 1, 0, 0, and a 1 times a 1, 0, 0, and a 1. And what I'm going to let you know is whenever you use a matrix like this to multiply it to itself, you're going to get the same answer out. But we'll go ahead and walk through the motions just to see how this one works out. And they actually want you to do I to the power of 4, which means we'll take this, the matrix times itself, we'll get an answer, and we'll take that answer and multiply it to itself, because that's what would happen if you had 4 of those. Because you're going to have I squared, and then you're going to take I squared times I squared, because I to the power of 4, just to be clear, I to the power of 4 is I times I times I times I. Well, this right here is I squared, and this right here is I squared. So once we find out what I squared is, we'll just multiply I squared to I squared to get the answer I to the power 4, which unfortunately is just, I'm letting the cat out of the bag. Total spoiler alert. We haven't done any math yet, but I'm telling you, this is the same as doing 1 times 1 times 1. We'll get the same answer. Let's go ahead and try this out. So I'm going to take a 0 and a 1, and I'm going to pick it up and I'm going to dump it in so that I have a 1 on top and a 0 on the bottom. I'm going to multiply those and add them. We get 1 times 1 is 1, and 0 times 0 is 0, and 1 plus 0 is just the number 1. I'm going to move that over. 1 times 0 is 0, 0 times 1 is 0, and 0 plus 0 is 0 for the first row, second column. We pick up the next one, we plug it in, right? So this time I'm going to end up with a 1 on the bottom and a 0 on top. So a 1 on the bottom and a 0 on top, and I multiply them and add them. So this is going to be 0 plus 0 is 0, and then I'm going to do 0 plus 1 is 1, and as you can see, I end up with the exact same matrix, 1, 0, 0, 1, and that is the same as I squared. So now I'm going to take I squared and multiply it to I squared. Well, that would be the same as 1, 0, 0, 1 times 1, 0, 0, 1, right? It's the two identity matrices multiplied together again, so that I to the power of 4 is just going to be 1, 0, 0, 1. Now, the neat thing is if you had a 3 by 3 or even like a 4 by 4, so let's say I had a 5 by 5, let's go nuts. So a 1, a bunch of zeros, a 0, a 1, and a bunch of zeros, a 0, and a 1, and a couple of zeros, a 0, 0, 0, and a 1, and then we'll squeak this last one in, 0, 0, 0, 0, and a 1. And if I did that and said I wanted 8 of those, so that matrix to the power of 8, right, it would end up being the exact same thing, just a bunch of ones and zeros. And that's what's known as the identity matrix. If I multiply that to any 5 by 5, I'll get the same number. You can try it on your own if you want. Not a big deal. But that's how that one works. Okay, so we worked those out. Great, lots of examples. There are some more examples over here. If you want to practice these are on the Google Classroom. They're also right here waiting for you. If you wanted to screen capture that and do some math, you can hit pause. If you wanted to screen capture this and do some math and hit pause. But it's also on your Google Classroom. There's a PDF for that. Here's some more practice problems that you could work on. These are problems very similar to the quiz that you would get if we were in class. And I'll go over these with you on Friday, but I want you to work on this fun between now and then. All right. Lots of to do there for multiplying matrices, just kind of killing time so that you can hit pause and run with it. Let's see, there is C times A there being sneaky in the corner. Go team. All right, guys. We'll see you later. Hope all is well with you and yours, and love you, and hope to see you soon. Go team.